Hey everyone, if you are running anything important on Azure, then you're going to want to stick around. We're about to pull back the curtain on the hidden tripwires that can take down your entire production environment, sometimes without you even knowing what hit you.
So what if you could actually see these things coming? What if you had a sixth sense for what was about to go wrong, and you knew exactly how to stop it in its tracks? Well, that's not some kind of superpower. It's just about recognizing the patterns, the ones other people have already paid the price to learn. And that's exactly what we're going to walk through today.
To get these answers, we didn't just read the manual. We went straight to the source. We're talking about thousands upon thousands of real-world Azure support tickets. We dug through all that data to find the repeatable, predictable issues that catch even the absolute best engineering teams completely off guard. This isn't theory, folks. This is intel straight from the front line.
And let's be clear, these are not edge cases. These are repeatable patterns that can hit any team, especially if you're scaling fast. So we're going to break them down into three main buckets, and we'll start with problems that come from a place you might not even think to look.
All right, so this first group of problems, it's a tricky one. We call it when the platform bites. Because believe it or not, the issues actually come from Azure itself. You know, all those necessary maintenance operations and updates.
So picture this, one of your critical VMs just reboots out of nowhere, no warning. If that machine was depending on its temporary storage or some local OS state, well, poof, you've got data loss, maybe a full-blown outage on your hands. The way to fix this is really architectural. You've got to migrate those workloads over to availability zones and, crucially, enable service health alerts so you can see these things coming.
Here's another one. A routine maintenance event happens and suddenly your database performance tanks. What's going on? Well, that maintenance can reset the database's internal stats, the very information it uses to run queries efficiently. It's like giving your database amnesia. The query optimizer gets totally confused, query times shoot through the roof, memory usage skyrockets, and your whole system just grinds to a halt. The fix? You have to monitor for these stat resets and get tighter on your session and memory limits.
Oh, this is a classic trap. I've seen this bite so many teams. You use the local temp disk on a VM for caching or session data, right? Makes sense. But then a maintenance event comes along and that disk gets completely wiped clean, gone. If your app wasn't built to be stateless, it's not going to recover. It's just going to crash. The real fix here, the long-term one, is to re-architect and get that state off the local disk and onto something durable, like Azure Files or a managed Redis.
Okay, so Azure does rolling updates across its availability zones, which is generally a good thing. But it can lead to some really bizarre staggered failures. You end up in this weird state where one zone is perfectly healthy, but another one is lagging or degraded. This causes all sorts of strange latency problems and can completely throw off your auto-scaling. The solution is to lean into zone-redundant services and really tune your load balancers to be smart, to actually route traffic away from a zone that's struggling.
And this isn't just a VM thing. The same idea applies in the Kubernetes world, for sure. We saw a great example where teams were upgrading their AKS nodes to Ubuntu 22.04. Suddenly, they're seeing these massive memory pressure spikes. What happens next? Pods start getting evicted and services start crashing, even under normal load. So the fix here is twofold. You've got to tune your memory eviction settings, but even more important is using phased upgrade pipelines. You catch this stuff before it takes down your entire production cluster.
Okay, let's move on to our next category, which is all about hidden configuration traps. Think of this as a minefield. These are the small, subtle mistakes that we make, the user-driven errors that are so easy to overlook, but can have an absolutely massive impact on your operations.
Here's a perfect example. You've got traffic coming through Azure Front Door, but when it hits your app service, your app doesn't see your nice custom domain. Instead, it sees the default.azurewebsites.net hostname. And that one little thing breaks everything. Your SSL certs don't match, your CORS policies go haywire, API calls get rejected. It's a mess. And the fix is deceptively simple. You just have to explicitly set the origin host header. But man, does this one trip up a lot of people.
And then there's the classic update everything at once trap. Making these big, broad changes without fully understanding all the downstream consequences, it's just a recipe for disaster. You update an entire resource group, not realizing a change to one shared network component is going to bring down a totally unrelated service. It's like pulling a loose thread on a sweater and watching the whole thing unravel. The only way to avoid this is with discipline. Use phased deployments, resource locks, and map out all those critical dependencies right in your infrastructure as code.
All right, for our last section, we're going to talk about hitting the cloud's limits. Because here's the thing we sometimes forget. Behind that illusion of infinite resources, the cloud is not, in fact, infinite. It has very real physical and logical boundaries, and when you slam into them, your operations can come to a screeching halt.
Has this ever happened to you? Your CI/CD pipeline just fails? You try to deploy a VM, and you can't. Why? Because Azure has literally run out of capacity for that specific VM type in that specific region. It happens. And it can completely block you from scaling out in production. The only way to deal with this is to plan ahead. You need to have alternate SKUs or even alternate regions baked into your plan, and you have to automate your quota monitoring so you're not caught by surprise.
And the last limit isn't about physical capacity, it's about visibility. You're basically flying blind sometimes. A platform reboot or a patch is scheduled, but it just doesn't show up in your normal monitoring tools until it's already happening, or it's over. Your ops team is completely blindsided. The only way around this is to get proactive. You have to build your own custom alerting, tapping directly into Azure Resource Health and Service Health. That's how you make sure you are never surprised by the platform again.
So, after looking at all these common failures, what's the big takeaway? What does it all mean? It's really about a fundamental shift in how you think. It's about moving from just reactively fixing problems to proactively designing your systems with the expectation that chaos is going to happen and building them to absorb it.
Which brings us to the final and maybe most important question you need to ask about your own systems. When things go wrong, and you know they will, is your infrastructure actually built to absorb that chaos? Does it gracefully handle the failure? Or does it take a small problem and amplify it into a massive system-wide outage? The answer to that question, well, it tells you everything you need to know about how resilient your system really is.